Good morning, everyone. Well, this is the best good morning I've gotten so far. Let's try it one more time. Good morning, everyone. That's so much better. So are you guys having a good time this week? This is great. The talks so far have been really amazing, and we've got a lot of good stuff lined up today as well. Here we've got sessions from Ash Furrow, Michael Klump, Michael Mace, Brianna Wu, Ray Wenderlich. We've got a games discussion panel after lunch. Sam Marshall, Aaron Hilgas, Jeff Kelly, and Mikey Ward. We've got some really excellent labs across the street at Jillian's, which again, in case you haven't already downloaded the betas and installed them on every device you have, we have them on thumb drives. Connected devices and analytics labs this morning, and then in the afternoon we've got a journalist pitch lab and networking and sync. One last thing, one of the big goals of this is that anybody who wants to come can come and learn and meet all the rest of you. So if at any time you don't feel like that's a thing you can do, you feel unwelcome, something weird happens, you feel unsafe for any reason, just find somebody in a blue shirt and they can help you out. If you can't find somebody in a blue shirt, the front desk can definitely help you. So our first speaker is a Canadian iOS developer who is living in Amsterdam right now. He has published 4 books and many apps, including functional reactive programming in iOS. He just started working at Artsy. Ash Furrow.
Good morning. As I was introduced, I'm Ash Furrow. I'm here to talk to you this morning about ReactiveCocoa. And before I do that, I want to start with a quote. In the expert's mind, there are a few possibilities. In the beginner's mind, there are many possibilities. In the expert's mind, there are a few. This is something that, when I read, really struck out to me. Because I think as developers, sometimes we get used to what we know, and we don't necessarily think about other possibilities and other ways we can work. And so when I first started learning about ReactiveCocoa, I was just blown away by how different it was. And later when I read this quote, I was just like, yes, this is the quote for the talk. So I want to go over the agenda this morning. We're going to talk about how imperative programming is dangerous, which is a strong word, but I use it. We're going to talk about functional reactive programming and how that mitigates that danger. And then we're going to talk about how to get started with functional reactive programming. First, I need to take you through a history lesson. So, as you probably know, computer science, technology, computers were invented, and we manually entered instructions through little switches onto a computer. And if we entered the correct instructions in the correct order, then when the program ran, the output satisfied the requirements of the program. We were happy. If we didn't make the right instructions, or we put them in the wrong order, it didn't. We were very sad. And then we invented something called assembler. So we didn't have to work with the instructions and the switches and the hex values. We could write in things like jump or branch, or instructions that we could understand that were translated into something that the computer could understand. And if we wrote the right instructions in the right order, then the output of the program satisfied the program's requirements. Great. And we invented a high-level language at the time called C. And C was great because it was a portable assembler. You could compile it on different platforms, and it was fantastic. But we were still writing instructions, and if we wrote the right instructions in the right order, then the output of the program satisfied the program's requirements. Fantastic. 1990s happened, a revolution in software engineering, object-oriented programming. Very cool. For the first time, we were able to reuse modules of our programs, but we were still writing instructions, and if we wrote the right instructions in the right order, then the output of the program satisfied the requirements. And nothing's really changed since then. Till now. Functional reactive programming. What is that? Well, let's decompose that. We know what programming is, so I'll skip that part. Functional. Functional programming is sort of pseudo understood by most people, including myself when I started down this path. Typically, you've got functions that don't have side effects. So if you have a function, you call it, the state of the system stays the same, even though you've called that function. Typically, you have immutability of state. So if you have a variable x and it's assigned to 5, x will always be equal to 5. There's nothing you can do to change it. Functional programming is really cool. I really dig it. I've used a couple different languages. My favorite is Haskell. The problem with functional programming is that it's hard to model the real world because the real world has state. And if you have things like input from the user, that's really hard to model in functional programming because that input is different every time it's done. Like the user isn't going to always input the same values. So that's really hard to think about in terms of functional programming. Reactive. The best metaphor I can come up with for a reactive program is a spreadsheet, which I know isn't really that exciting. Although I do have a friend who insists that you can do everything with Excel that you could do in a Turing-complete language except directed acyclic graphs. And I think that's pretty impressive. So imagine you've got a cell, A, and that cell is bound to the values of B plus C. If you change the value of B or C, then A is automatically updated. It reacts to the changes in B and C. Those changes are propagated throughout the system until they're done. Cool. So that's reactive programming. And if we can combine them together, we get this peanut butter and chocolatey goodness of functional reactive programming. It's really like it takes the best of functional programming and marries it with this reactive programming so that we can model difficult things like state, or input rather. So, functional reactive programming. Just to recap, functional programming is great, but it's hard to model because side effects. Reactive programming is sort of limited by itself. And the way we get around the whole functional thing is it's a cheat. I'm letting you in on the dirty secret of functional reactive programming. We model time as an implicit variable into things so that time is never the same thing twice. So if you think about it, a function that always returns the same thing with the same input values, if time is always an input value, then you're allowed to have different return values over time. That's like the meta version of like how we get around this whole functional thing. At the core of functional reactive programming is something called a signal. A signal sends values over time. It doesn't have any concept of a current value or past values or future values. It just sends things. It's kind of like a pipe. A pipe doesn't know what's in it. It just, things go through it. Yeah. A signal can complete, and then at that point, no further values are sent down it. Or it can error, which means it sends an error value and no further signals are sent, values are sent. A signal either completes or errors, but not both. Okay. A little bit more on signals. You can chain signals together using what are called signal operators to do some really cool things that we're going to take a look at in a little bit. This is really core, like as core as signals are to FRP. Signal chaining is really core as well. And we're going to take a look at that. And if you're a math nerd, as I hope a lot of you are, as I am, you can think of it like this, f of g of y. So you have f of a function of some value, and you can put another function in there. We're going to take a look and see what that looks like. ReactiveCocoa is an implementation of functional reactive programming for Cocoa and Cocoa Touch. So you can use this on Mac apps as well as iOS apps. And it's really cool. It's developed by some very smart engineers at GitHub. Originally, I talked to the engineers and I asked, what was your inspiration? And .NET has reactive extensions for writing Windows applications. And they said that they were jealous of the code that their colleagues got to write. So they decided to write a library themselves, which I really thank them for because it's amazing. Yeah, it's currently on its way to 3.0. a really great simplification of the library. Everything I'm going to tell you about today applies to ReactiveCocoa 2.x and 3.0 because they're core concepts. So let's return to signals. Most signals are built on key value observation, which is a technology that as Cocoa developers we're very familiar with. You can create a signal very easily with the RackObserve macro. Basically, it wraps a property value, and then whenever that property changes, the signal emits a new value. We'll see an example of that very shortly. Yeah, we'll see an example now. So in this example, I've got rack signal equals RackObserve, an object, and number. Number is a property on the object. It does it does compile time checking to make sure that number is actually a property on that. Then, what's really cool is I can subscribe to that signal so that whenever it sends new values, I do something. This is kind of a bridge between the functional reactive world and the imperative world, where we've got things like side effects that we need to do. If you ever have a side effect that you want to accomplish, put it in a subscribe block. And that's where you can do things like reload your table view if you're observing the backing data source as a signal. And whenever that data source changes, it sends a new value. You want to do something with that value, like reload a table view, this is where you would do it. Signals always send objects, never primitives. So it'll automatically take care of wrapping things like properties of primitives like bools and floats for you into NS number and NS values. Even things like CG rect and CG size and things like that, it'll automatically wrap those for you, which is really cool. So now we're going to talk about some operators. Map is a really cool operator. We saw this earlier this week with the new Swift language, has mapping built in. It's a functional concept, but it's going to become a lot more prevalent in iOS and OS X development. So mapping takes a signal that sends values, and whenever that signal sends a new value, it maps it into a new value, and then emits that one. So it takes a signal, does something to it, and then it returns a signal that sends new values. And I have a diagram, so don't worry. We see we've got RackObserve up at the top. That's how we create signals over KVO. That feeds into the map operator, which creates a new signal that emits new values. Code for that looks like this. So we've created a signal just like we were doing before, and this signal is going to emit NS number values. We're going to use a map function to take those values and turn them into strings. And it's just it's a block-based API. The code here isn't it shouldn't be too unfamiliar, but I know that there's like the one thing I've heard from ReactiveCocoa newcomers is that the amount of opening square brackets at the beginning of your line tends to get rather large. But don't worry, you'll get used to it. So in this case, we're mapping numbers to strings, and then we want a side effect. We want to log those strings, so we do that at the end. Okay. This is really cool. If you have two or more signals, you can combine them and then take the values that are sent from those two signals and emit a new signal that transforms those values. This is useful for two main use cases. If you want to decide between two values, then you can do this. Or if you want to wait until two conditions are met. So what that looks like in a diagram is this. RackObserve's at the top. You've got combine latest in the middle. Takes the two signals and emits a new signal that only sends one value. Code looks like this. Got a rack signal. It's a class method on rack signal. Combine latest. You give it something that conforms to the enumerable protocol, usually an array. And then you pass in a reduce block. This is really cool, I think. The reduce block returns id, or id, however you say it. And then you've got a parameter list of the values that have been sent on the signals that you just enumerated over. So if you have 2 signals, you've got 2 parameters. If you've got 3 signals, you've got 3 parameters. It's really cool. It'll automatically do whatever you want it to do. In this case, what we're doing is combining those 2 values into one and returning a new string with that's been formatted for us. So we've got some number signal, some string signal, combining them together in the reduce block and returning that value, which we could later subscribe to or do something else. Another operator that's really common is filter. Filter is useful if you want to have a signal that sends some values, and you want to stop some of those values from continuing on through the fall through. So if you've got a number signal and you only want to return numbers that are greater than 5, then you can do that really easily. From a diagram perspective, it looks very familiar, just like map. Takes a signal, does something with it, returns a new signal that sends values. The code looks like this. You've got some number signal. Filter returns a bool. It takes the values, the block takes the values, it evaluates those values and returns yes or no. If it evaluates to yes, then the signal here just sends those values as is. If it returns no, then it doesn't. This has all been kind of academic because we haven't really covered how to do really cool things like anything really. Everything I've told you so far has been like, okay, we've got signals, it's great, but how do we actually do stuff with it? This is where bindings come in. This is really cool. Do we have any OS 10 developers in the room? Wow. Okay, so like 3. Awesome. I've done some OS 10 development, and one of the wildest things that I found were Cocoa bindings. And I know that's a contentious topic because they're hard to debug and whatever, but they were really cool to me as an iOS developer coming to the platform for the first time. And they worked in Interface Builder. Oh, it was amazing. Bindings exist in ReactiveCocoa as well. Typically, they're created with a rack macro. We'll see what the code looks like shortly. Basically, if you've bound a property of an object to a signal, whenever that signal sends a new value, then it'll automatically be set on the object it's bound to. So I'll take a look at an example. We have rack self.text field, comma text, is equal to rack observe, self, some string. This means that on the right-hand side of the equal sign, we've got rack observe, that creates a signal. Whenever some string is updated, that signal emits that string's value. On the left-hand side, we've got the rack macro, and the text property of the sum text field, of self.text field, will be updated automatically to the values emitted by the signal on the right-hand side. Okay. Let's look at a little more in-depth example. Say I have an array of signals, like ReactiveCocoa introduces extensions into iOS and OS 10 on existing classes, or rather categories on existing classes. So here we've got a text signal from 2 text fields. So whenever the user changes these text fields' values, these signals emit new values. What we're doing is we're binding the enabled property of a button to be a combination of those 2 text field signals, and then we're reducing it into a signal that returns a Boolean that is making sure that the first name and the last name, their length is both greater than 0. So again, we're taking a signal array, 2 text field signals. They change whenever they emit new values whenever the text fields change due to user input. And then we're binding that to a reduction of those 2 signals and binding that to a button's enabled state. Something that's really key to ReactiveCocoa is the idea of derived state. State in Cocoa programming, Cocoa Touch programming is kind of hard to get away from. You can't really write apps without having some instance variables or some properties that change over time. It's just the way that the Cocoa and Cocoa Touch libraries are written, it's really hard to get away from that. And ReactiveCocoa takes a pretty moderate approach to this. It says state is fine. Things can change, things will change. as long as we're binding that state to some signal. We're deriving the state from a series of signals that change over time instead of calculating that state ourselves. There are a few other operators that I haven't been able to talk about. Take until, that's really cool. You can stop a signal from emitting new values once another signal sends a value. Schedule on is really good for threading. So ReactiveCocoa introduces the concept of a scheduler, which is a higher level concept than a thread or a dispatch queue. And you can schedule things on the background thread scheduler or the main thread scheduler, which is really cool for doing things like a lot of data processing on the background scheduler and then returning to the main thread scheduler in order to update the UI. Throttle, really cool. Say you've got a search text field that every time the user changes the text, queries your API in order to return new search results. But you don't want to do that for every character the user types. So you could throttle that to only emit a new value every second, say. And then you go from like, someone types in 5 characters in a second. Instead of sending 5 API requests, you send 1. Pretty cool. Not, and, and or. Those operate exclusively on signals that send Boolean values, and they just do exactly what you think they would. One topic that I almost didn't include in this talk is the idea of a command. Commands are going away in ReactiveCocoa 3.0. They're difficult to describe. They represent a unit of work that's done typically in response to user interface interaction. If I were you, I would just recommend avoiding commands. Use subscribe next for your side effects instead. I'm sure I've got the ReactiveCocoa developers like yelling at me right now, being like, "No, commands are great." Yeah. Another really cool thing I want to talk about briefly is the idea of two-way bindings. When I found these, I was just like, so cool. So if you have a property on an object, a property on another object, whenever one changes, you want the other to change, and vice versa, you can use the rack channel 2 macro on both sides of the equal sign in order to bind those two properties together. Really neat. I don't really have time for a demo, but you can look on my GitHub page, and there's a couple projects on there for how to use ReactiveCocoa, including one called C41, which is an entire application written in ReactiveCocoa. It's on the App Store. You can download it and play with the source code. But I just wanted to talk about what I would have talked about in the demo, recap that. Subscribe next, used for side effects. Rack observe captures self in its scope implicitly, which is something that I believe is changing in React 3.0. So you need to avoid a reference cycle. If you're using self in, like if you have rack observe inside a block that's being stored somewhere, you need to weakify self first. It's kind of an edge case. You don't do it that often, but I wanted to mention it. Network results are delivered on background schedulers. So use deliver on to shuffle them into the main thread scheduler. Okay. Something that's not exactly related to ReactiveCocoa, but I really wanted to mention is the idea of model view, view model. As Cocoa and Cocoa Touch developers, we've all heard of model view controller. It's how we have historically structured our code in such a way that it makes it reusable. And model view controller has served us pretty well. The problem with model view controller is that you usually get to something like a massive view controller, where you've got hundreds, maybe thousands of lines in a view controller, and it's managing state, and it's completely out of control. It's hard to keep track of everything that's going on. And we want to kind of take a new approach to that. Model view view model formally connects views and view controllers into one object. Not one object, but one like logical object. I mean, how many times have you got a view controller subclass and a view, and you use the same, a different view with the same view controller? It doesn't happen that often. Usually view controllers or views are bound very tightly together, so why not just formalize that connection? This is what the diagram looks like for model view view model. You've got the view and the view controller on the left-hand side, connected as sort of one logical entity. Got the model on the far right-hand side. That's your typical model. Maybe it's a mantle object or core data object. In the middle, we've got our view model. This is really cool because it can represent all the presentation logic that you want to do. So you put all the stuff that you would normally have in your view controller, like taking a date and formatting it, or data processing, network stuff, all the things that really don't belong in a view controller anyways, put it in your view model, and then you can test it with unit tests really easily. You can reuse your view model if you want to, but it's sort of an advanced topic. So how do you get started with ReactiveCocoa? It's pretty easy. Install ReactiveCocoa either with CocoaPods or Git submodules, and then start by replacing your key value observation with signals that you subscribe to. It's a very simple use case. Yes, there are libraries out there like BlocksKit that will let you use block-based APIs for KVO, and they're great, and you should use them if this is all you want to use ReactiveCocoa for. But having KVO signals is a really great foot in the door into functional reactive programming, and soon you'll start mapping those, and then you'll bind them, and then it lets you grow as a developer with using this library. If you'd like to learn more, I published an ebook on this at leanpub.com/iosfrp. Pretty easy to remember. It's a pretty short book. It's about 100 pages, but it takes you through everything from the very beginning of functional programming, what is map, what is reduce, what is fold, that kind of stuff, and takes you through how we build up from there to something like a fully functional reactive application. All of the code for this book is open on GitHub, so you don't even have to buy the book. If you just want to look at my GitHub profile, github.com/Furrow, and take a look at the code, it'd be great. Pull requests welcome. If you have any questions, I'm on Twitter at @Furrow, or you can go to my website. I'm happy to answer questions about ReactiveCocoa. I really love talking about this stuff. I really appreciate your time. We've gone through the basics of how we do, how we've done imperative programming, how that has dangers. We looked at how functional reactive programming kind of mitigates those dangers by abstracting state away and mutable state. And then we looked at how we actually do functional reactive programming on iOS and OS 10. So I really hope you've enjoyed this talk, and I'll see you the rest of the week. Thank you. Do we have time for questions? Okay, great. Does anyone have any questions? Someone must have a question. Okay. Back. Oh, sorry.
So one of the problems I've had with two-way binding with the MVVM model is understanding, what should be bound, what like an ownership versus an update means, and not having, for example, circular loops down that whole chain.
Yeah. So in MVVM, what you would typically do is you've got a property on your view model and a property on your model, and you would use KVO signals to bind that one way to your view model, and then you can use things like map and filter and stuff like that. And then your view controller, which is typically very short, what you would do is bind that with a two-way binding, so that if the view controller changes the value of a text field, that can propagate to the view model immediately, and then onward to the view, and vice versa. Does that answer your question?
So only at the very end do you do the two-way?
That's
and
right.
Then, okay, then how do you, in that case, does that mean you only, like what happens if you have a model that actually can change independently of the interface?
That's a good question. It's pretty common in any view model that does network code. In that case, your view model would be the one updating the model, so it could update the model, which would propagate through the view model itself, and then onward to the view. So it's sort of a level of indirection, but it still works. Any other questions? Oh, we've got one down here.
Wait.
Hi.
Hi. So I get into the this kind of structure a few months ago, and I want to use it in my company's project. So my company's developed drones, the flying machine, and we need to use the iPhone to connect to the device with Wi-Fi and UDP and TCP this connection.
Cool.
And we define our protocols, but we use a lot in structure and enum. So can this to up to observe for the structures, values change, and reflect on the interface? And what does the speed, will it improve rather than using the KVO?
Mm-hmm. Okay, so it's two questions. Can you use custom structures in enums? Yes, you can. NSValue has categories on it for things like CG-rect and CG-size, CG-point, all those things. So you can define your own categories on NSValue, which are going to be the values sent out by a signal, in order to unbox those into something that you can actually use. So that's pretty easy. As far as speed improvements go, I find ReactiveCocoa doesn't introduce a lot of overhead at all, but there's one caveat. When you're running it in debug mode on a device directly connected to Xcode, for instance, it introduces a lot of overhead logging and things like that for your benefit while you're developing. And those loggings are disabled for release mode. So it's actually a lot faster when you're releasing than when you're developing. So I've had some questions come in, like scrolling performance isn't very good, and invariably I tell them, like, compile in release mode, see what happens, and it just works great. So, yeah. Cool.
How do you see Swift's will set and get set and did set stacking up against this?
Good question. So Swift has this concept of inside of your properties, you can have will set, did set methods that are invoked, kind of like KVO, which is really cool. I'm actually really excited to see where functional reactive programming on iOS and OS X is going. I saw last night that Justin Shahr-Summers at GitHub created, I think it's RX Swift. So I'm very excited about that. Whatever happens, I'm really looking forward to contributing to that library and helping get the word out about functional reactive programming. Anybody else? Okay. Great. Thank you very much. I don't know where to go now.
So we're just he has published 4 books and many apps, including functional reactive programming in iOS. He just started working at Artsy. Furrow.
Good morning. As I was introduced, I'm Furrow. I'm here to talk to you this morning about ReactiveCocoa. And before I do that, I want to start with a quote. In the expert's mind, there are a few possibilities. Oh, sorry. In the beginner's mind, there are many possibilities. In the expert's mind, there are a few. This is something that, when I read, really struck out to me. Because I think as developers, sometimes we get used to what we know, and we don't necessarily think about other possibilities and other ways we can work. And so when I first started learning about ReactiveCocoa, I was just blown away by how different it was. And later when I read this quote, I was just like, yes, this is the quote for the talk. So I want to go over the agenda this morning. We're going to talk about how imperative programming is dangerous, which is a strong word, but I use it. We're going to talk about functional reactive programming and how that mitigates that danger. And then we're going to talk about how to get started with functional reactive programming. First, I need to take you through a history lesson. So, as you probably know, computer science, technology, computers were invented, and we manually entered instructions through little switches onto a computer. And if we entered the correct instructions in the correct order, then when the program ran...
Well, here we've got sessions from Furrow, Michael Klump, Michael Mace, Brianna Wu, Ray Wenderlich. We've got a games discussion panel after lunch. Sam Marshall, Aaron Hilgas, Jeff Kelly, and Mikey Ward. We've got some really excellent labs across the street at Jillian's, which again, in case you haven't already downloaded the betas and installed them on every device you have, we have them on thumb drives. Connected devices and analytics labs this morning. And then in the afternoon, we've got a journalist pitch lab and networking and sync. One last thing. One of the big goals of this is that anybody who wants to come can come and learn and meet all the rest of you. So if at any time you don't feel like that's a thing you can do, you feel unwelcome, something weird happens, you feel unsafe for any reason, just find somebody in a blue shirt and they can help you out. If you can't find somebody in a blue shirt, the front desk can definitely help you. So our first speaker is a Canadian iOS developer who is living in Amsterdam right now. Good morning, everyone. Well, this is the best good morning I've gotten so far. Let's try it one more time. Good morning, everyone. That's so much better. So are you guys having a good time this week? This is great. The talks so far have been really amazing, and we've got a lot of good stuff lined up today as well.
The output satisfied the requirements of the program. We were happy. If we didn't make the right instructions, or we put them in the wrong order, it didn't. We were very sad. And then we invented something called assembler. So we didn't have to work with the instructions and the switches and the hex values. We could write in things like jump or branch or instructions that we could understand that were translated into something that the computer could understand. And if we wrote the right instructions in the right order, then the output of the program satisfied the program's requirements. Great. And we invented a high-level language at the time called C. And C was great because it was portable assembler. You could compile it on different platforms, and it was fantastic. But we were still writing instructions, and if we wrote the right instructions in the right order, then the output of the program satisfied the program's requirements. Fantastic. 1980s, 1990s happened.